All right, the bottom of page 5. We are getting closer to discovering what radian measure is. Okay, but before we do that, we need to talk about arc length. Okay, so let's look at the first bullet point that's there. It says that a central angle theta is a positive angle whose vertex is at the center of a circle of radius r. Okay, so what I have below here is a circle, and the circle has radius r. Okay, so remember, radius is the distance from the center of the circle, okay, to any point on the circle. Okay, so here's your radius. The radius we're saying is r. We don't know a specific number for the radius, and that's okay. We're just looking at this from a generic perspective. And we're assuming this to be a positive angle. So if you notice, the rotation is going from the initial side, and there's a small arrow here indicating that it has gone counterclockwise to the terminal side. Okay, so we have a positive angle, and what makes this a central angle is that the vertex is at the center of the circle. Okay, so that little black dot there, that's the center of the circle. Okay, so keep in mind that, or what a central angle is. So a central angle theta is a positive angle whose vertex is at the center of a circle of radius r. Okay, so here comes the concept of arc length. Okay, and that concept of arc length is going to help us discover what a radian is. Okay, all right, so in the second bullet point, what does it tell us? It tells us that the rays of the central angle subtend, which means intersects, an arc on the circle. The measure of the distance along the curve making up the arc is called the arc length, and we usually denote that with the letter S. Okay, so what this is saying, okay, how arc length is defined: if you have a circle and you've got a central angle drawn, what you should notice is that the two rays that make up your angle, they intersect the circle. Okay, and what happens here, if you trace the curve along the circle between those two intersection points, okay, it traces out a little path on the circle. Okay, and if you were to take this, okay, this yellow piece that I've highlighted, imagine that the circle was made out of a piece of string. Okay, if you were to take a pair of scissors and snip the circle at those two intersection points, so right here and right here, and then you took the string that was left, the yellow part of the string, and you stretched it out, and you put it along a ruler, and you measured how long that piece was, okay, that's the length of the arc. Okay, that's the arc length. Okay, we usually designate arc length with the letter S. Okay, but that is all the arc length is. Okay, you've got this central angle, it intersects an arc on the circle. Okay, so like I said, the best way to imagine it is that the circle is made out of string. You go in with a pair of scissors, you snip the circle at the two intersection parts, and then you take at the two intersection points, and then you take the piece of the circle, for, where the where the central angle subtended, and then you just stretch out that piece of string that you were left with, and you measure how long it is, and that's the arc length that we're talking about. Okay, it is designated S. Okay, and there's actually a formula for it. Okay, so if you scroll below the circle, there's going to be a formula that tells you how to calculate arc length. Okay, so it says for a circle of radius r, a central angle of theta radians subtends an arc whose length s is given by s is equal to r times theta. Okay, so what this is saying, okay, this little formula, the arc length formula is S, which is arc length. It's equal to the radius times the central angle theta. Okay, you multiply the radius and the angle together, and you get the arc length. Okay, what you need to know in order to use this formula is that theta must be measured in radians. Okay, which we haven't exactly defined it yet. We're going to do that on the next page. Okay, but in order to use the arc length formula, theta, or whatever your central angle is, it has to be measured in radians. Okay, so let's think about it this way. This is a good way you can remember that little fact. Okay, this yellow portion of the circle, like I said, if it were a piece of string and you stretched it out and you measured how long it was, you're calculating a length of something. Okay, so you might be measuring it in feet, you might be measuring it in meters, inches, whatever. Okay, so if your angle were measured in degrees, okay, think about your units. Okay, your units would be r, which is the radius. The radius is itself a length, so it would also be measured in like inches or feet or whatever you're using. So this would be like, let's say we were using inches. This would be inches times degrees. Okay, that would be your units. Okay, that doesn't make any sense. You don't measure, you're trying to calculate the arc length, so you should be expecting inches as the measurement. Okay, or as the units of measurement. Okay, so what's going on here is that the angle has to be in radians. I think I've mentioned this to you before, even though we haven't talked extensively or pretty much at all about radians. Radians are unitless. Okay, so if you did this, okay, because we know that our angle has to be in radians, okay, then r would be measured in inches, and then the angle is measured in radians, so it's unitless. Okay, so inches times unitless is going to be inches, and so then it gives you the correct units for the arc length. Okay, so there you go. All right, so what you need to know is you need to understand what arc length is. Okay, it's the length of a particular curve along the circle. Okay, and you can calculate it. Okay, it's usually referred to as S. You just do the radius times the angle, but the angle has to be measured in radians.